Okay, guys, last section of 2.4, rates of change in tangent lines. So you're going to see some things kind of come back. You guys can pause this video to be able to write down all of the information. I'll explain it a little bit. So after this section, we're going to be able to say I can find the slope of a curve at a point, and I can write the equation of a tangent line and a normal line. Now remember, the average rate of change is the change of y, so change in the amount over the change in time. We can also write it as f of b, which is the change minus the initial over the change in time. Now we're going to start, basically the rate of change is also known as the slope of the secant line. So if we have a curve, I'm just going to draw a parabola. The secant line is basically pick 2 points on the parabola, and it is the line that intersects those 2 points. So this is called the secant line. Now the slope of this line is the average rate of change. Next up, we have the instantaneous rate of change. Now we're going to know this as the slope of the tangent line. So what is a tangent line? The tangent line is basically at a point, if you draw a line, a straight line that goes through that point, sorry, it's not supposed to intersect the curve, okay? The tangent line is more like on the outside of the curve. And there we go. This guy is the tangent line. And the slope of this line is the instantaneous rate. Now remember, the instantaneous rate is basically finding the rate of change at a specific instance. So it's the limit as h approaches 0. If you take, let's say that a is 2 seconds, it's 2 plus a small amount of time minus the initial 2 seconds over that small amount of time. So this right here is the slope of the tangent line. And then the last thing is the normal line. The normal line is the line perpendicular to the tangent line. So if we draw a line directly perpendicular to this tangent line, and remember, perpendicular means there has to be a 90-degree angle, that is called the normal line. To find the normal line, we need to know a point and a slope of the tangent line. So we're going to have to find the instantaneous rate of change of the tangent line and know another point on that line. Okay? So now let's actually start doing some examples. So the first example says, find the average rate of change of this equation, x cubed plus 1 over 2 to 3. So basically what this means is this is the end point and this is the initial point. So we want to find the rate of change. And remember, the rate of change is change of y over change of x. So change of y would mean that we'd have to plug in 3 and subtract it from the plugged in 2. So it's f of 3 minus f of 2. And then the change of x, these are the x values, so it's just going to be 3 minus 2. So f of 3 means plug in 3 into this equation, so it's 3 cubed plus 1 minus 2 cubed plus 1, and all of that is going to be over 3 minus 2, which of course is 1. So once you do this operation, so 3 cubed plus 1 is 28, plus 2 cubed plus 1, I'm sorry, it's not going to be plus, it's going to be minus, 9 over 1. and 28 minus 9 is 19 over 1. So the average rate of change, aka the slope of the secant line of that curve, is 19. Now in this specific problem, there's no units because it's not a word problem, so don't worry about the units. Okay? All right, second example. Find each of the following for this function. Y equals 1 over x minus 1 at x equals 2. So this right here is the instant, okay? All right, so before I do anything, I want to graph this function. Now this is a rational functions, which means it's going to have two branches. The vertical asymptote is at 1, so I'm going to draw a vertical asymptote through 1. And then our horizontal asymptote, it's bigger on the bottom, so it is 0. We don't have any holes because nothing cancels out. And now I'm just going to pick some points and graph this line. So when x is 2, y is 1. Okay. And I don't have to have a perfect graph, but I kind of know that the branch, once I graph this on the calculator or pick some more points, kind of looks like this. And then the other branch is here. So when x is 0, we are at -1. And then I just wanted one point to kind of be able to draw my graph. So what this question is asking is find the instantaneous, well, A, it says find the slope of the curve, which means I want to find, A is asking to find the instantaneous rate of change at x equals 2. So right there. So I want to find the tangent line, the slope of this tangent line at x equals 2. So we know that it's f of 2 plus h. Remember that h is a small amount at around 2 minus f of 2 over 2 plus h minus 2. So now when we plug in 2 plus h, you're going to end up with, into this equation, okay, you're going to end up with 1 over, instead of x, I'm going to put 2 plus h minus 1, and then minus 1 over 2 minus 1, and all of that is going to go over h, because 2 plus h minus 2 is h. And remember, we're finding the limit as h approaches 0 because that's the instantaneous rate. Okay, and now how did I know to find the instantaneous rate? Because remember, the slope of the curve is the instantaneous rate. And because it's at 2, it's going to be the tangent line and not a secant line because they didn't give us 2 points to cross through. All right, so I'm going to continue solving this. So now the limit as h approaches 0, I'm going to simplify this out, which ends up giving us 1 over 1 plus h minus 1 over 2 minus 1, which is 1. And all of that is over h. Okay, now here I'm going to need to get a common denominator so I can combine these two. So I'm going to multiply the top and the bottom by 1 plus h. So then I get 1 minus 1 minus h, okay? Or I can do this, 1 plus h, and then you'll know that that minus is going to distribute later. All of that is now over 1 plus h, and that is over h. All right, keep going to simplify. 1 minus 1 is 0, and then the negative 1 is going to make that h. I'm sorry, I just got to check my work really quick. That is going to make this h a negative h over 1 plus h, and that is all over h. All right, now remember that this h is technically over 1, so when we multiply by the reciprocal, we're going to multiply by 1 over h. So what happens here is that this h cancels out, and then we're left with negative 1 over 1 plus h. And remember, we're trying to find the limit as h approaches 0. So now when you substitute 0 in for h, you end up with a negative 1 slope. So that is the slope of the curve. All right, B says find an equation of that tangent line. So remember, we already got the slope of the tangent line. So we have the slope is negative 1. We have a point, which is at 2, 1, because at x equals 2, I know that it's 1 when I plugged it in. And now this is old school algebra 1. We use y equals mx plus b. Or you can use the point slope form, okay, whatever you're more comfortable with. I'm going to plug in my y, which is 1, my slope, which is negative 1, my x, which is 2, plus b. I solve this out and I get b is 1 minus 2, which is negative 1. So now my equation of my tangent line is y equals m, which was negative 1x, minus 1. Okay? And then C says draw a graph of the curve. Draw the graph of the curve, which we already did. We drew the tangent line. And now I'm going to draw the normal line in the same square viewing window, which means right over here. So remember, the normal line is going to be perpendicular to our tangent line. So there's my normal line. Now it doesn't say find the equation of the normal line, but remember the equation of a line perpendicular is going to have a flipped slope, but the same y-intercept. So the equation of this line should be y equals x minus 1. So now my slope, instead of being negative 1, it's going to be positive 1. Okay, and if it was a fraction, it would have been flipped around. All right. Last example, an object is dropped from the top of a 100-meter tower. Its height above ground after t seconds is given by this equation. How fast is it falling exactly 2 seconds after it's dropped? So by them saying exactly 2 seconds, that means they want that instant. So the f of t equation that they give us is 100 minus 4.9 t squared. And that's going to be in meters, so remember that for the final answer. And we want to find the instantaneous rate of change at 2 seconds. So that means f of the limit as h approaches 0 of f of 2 plus h minus f of 2 over 2 plus h minus 2. Remember, see, I always write this, but if you can just remember that it's always going to be h down here, that's fine. All right, so now I'm going to plug in 2 plus h into t. So 100 minus 4.9, 2 plus h squared. And that's going to subtract from f of 2, which is 100 minus 4.9 times 2 squared. And all of that is going to be over h. So when we clean this up, okay, we're going to end up with, first I'm going to start off by foiling this one out. So I have 100 minus 4.9, and then this is going to be 4 plus 4h plus h squared, because 2 plus h squared. Oh. And then minus, sorry, I need my calculator for a second. So minus 100 minus 4.9 times 4, and that's 80.4. All right, so once we distribute this out, we're going to get 100 minus 4.9 times 4, which is 19.6, minus, because remember you're distributing that negative 4.9, 19.6h minus 4.9h squared, and then bring down the minus 80.4. All right, so here, let's clean up all of the numbers. So 100 minus 19.6 minus 80.4 is, of course, 0, which I could have seen that from over here. I could have canceled those hundreds out, but it's okay. So that is 0. So we're left with, and I kept on forgetting this h down here. Oh my God, don't do that. 19.6h minus 4.9h squared, all of that over h. So you see here that these two have an h in common, so I can take out a GCF of h. And just to make it easier on me so it doesn't look ugly inside the parenthesis, I can take out a negative h, and then we're left with 19.6 plus 4.9h over h. These h's cancel out. So we're left with negative 19.6 plus 4.9h. So now, what is the limit as h approaches 0 of that function? It's going to be negative 19.6 plus 4.9, or minus, sorry, well, here, let's do that, plus 4.9 times 0, which of course that turns into a 0, so it's negative 19.6. Now the reason it turns out to be negative is because the ball is going down, so you wouldn't say that it went negative 19.6 meters, you would say the ball fell 19.6, or an object fell 19.6 meters from the tower. So that's why it was a negative. Because if it was positive, that means you're throwing the ball upwards. All right, good luck. So I want you guys to finish up the homework also before class on Monday. And I'm sorry this took a little bit longer to post this video. I had it recorded, couldn't find it on my computer, and I had to redo it, but I wasn't feeling 100%. So good luck, enjoy, and see you guys on Monday.